Okay, so I'm going to go over 4 or 5 problems that students have asked. So hopefully this will help a little bit, just in case, or at least give you a little more confidence. So 29a is the log of base 3 of 1 over 27. The whole point is that you want your base, the 3, to be the same as the base in the parentheses, if you can make it that way. And you can make 27 3, except it's in the denominator. So let's change our colors here. Log base 3 of 1 over 3 cubed is 27. Okay, so if we can put that in the numerator, that would be great. And we do know how to do that. So this would be the log base 3 of 3 to the negative 3. And whenever you move something, the base to a different position, top to bottom or bottom to top, you change its positive or negative sign. So 1 over 27 is the same thing as 3 to the negative 3. And since both of these are the same, the answer is just negative 3. Okay? All right, let's go on and do the next one. 33a. The log base 8 of 0.25. Okay, so this is a little bit harder. We need to get the 0.25 to have a base 8 or something very similar. So let's work this out a little bit. Let's go and say that this is log base 8 of 1/4. Okay, and again, we can change it like the one above it into log base 8 of 1 over 2 squared. And then put that in the numerator, log base 8 of 2 to the negative 2. Except that doesn't really help us unless we can get the 8 to be a 2. All right, so if you remember, we set this equal to x. We can do this little counterclockwise motion and say that 8 to the x is equal to 2 to the negative 2. Okay, so again, how do I make the 8 a 2? So let's work this down and say that 8 is 2 cubed. So I just separate or change my bases. And anytime you raise an exponent to an exponent, you multiply them. So let's rewrite this as 2 to the 3x equals 2 to the negative 2. And any time that you have your bases the same and they're equal, then their exponents must be equal. So let's solve this as 3x equals negative 2, x equals negative 2/3, and that would be the answer. And yeah, it took a long time to get there, showing every little step to make sure that there aren't any questions. You have to get the bases to be equal. All right, so let's go to the next one. And that was a hard problem. Now let's go to the next one. On the quizzes and tests, I'm not going to give you really difficult problems, but you still need to know how to work these out. All right, so let's get a blank screen here and do 37a and b. All right, 37a. Okay, so here we have the natural log of x equals 3. And you know that the natural log means really log base e. So if we do our counterclockwise motion here, we get e to the 3rd equals x. And that would be the answer. Okay, so part B, you're just putting it in exponential form for that. Part B is the natural log of e squared equals x. Okay, so again, this is the log base e of the e function. And anytime, I did mention in our notes, that anytime these are the same, the answer is just the exponent. So really x should be equal to 2, but let's just go ahead and follow through with our counterclockwise motion, and you get e to the x equals e squared. So if the base is the same, then the exponents are the same. So x equals 2. The shortcut is if these two are the same, then the answer is the exponent. Okay, so x is equal to 2, and we showed that in the second step there. All right, let's go on to the next one. All right, so we are at 43a and b, so let's take a look at that. Now this is the log base x 16 equals 4. Again, we are just putting these in exponential form, so we use our counterclockwise motion, and this would be x to the 4th equals 16. And do we know what that answer is? If you can take the 4th root of both sides. So the 4th root of x to the 4th is x. The 4th root of 16 is 2. Okay? And B, part B, is log base x of 8 equals 3/2. Again, let's go ahead and put this in counterclockwise motion in exponential form. X to the 3/2 is equal 8 to the 1st. Okay, so to remove an exponent, you have to take the root of it. All right, so if we... Okay, so instead of taking the square root, there's other things we can do. Typically, when you do the counterclockwise motion, it does set you up. X to the 3/2 equals 8 to the 1st, okay? And then you should be able to work it from there. But here's a little hint of what you could also do. You can raise your exponents to an exponent. Let me go ahead and change this to 2/3. If I raise both sides to 2/3, what I get here is x to the 1st. So x to the 1st is equal to 8 to the 2/3. When you multiply, when you raise an exponent to an exponent, you multiply. So that would be 6 over 6, or 1. We want it to be x to the 1st power. So you have to learn how to use all the skills you've been taught to manipulate these things. So in our notes, hopefully you saw that. If not, there you go, you have it. Now you have to figure out what 8 to the 2/3 is. You cannot leave it like that. You can figure out what that is. So there's two different ways we can go about doing this. I'm going to solve it two different ways, and you get the same answer. You must remember that the bottom number is your root, and the top number is your exponent. So it could be the cubed root of 8 squared. And you should also know that the 2 can go on the inside, or you can move it to the outside and do it last. So on the left side here, I will do it first. And on the right side, I will do it last. All right, so 8 squared is going to be 64. The cubed root of 64 is 4. Excuse me. If we do the exponent last, we have to do the cubed root of 8 first. The cubed root of 8 is 2. And then we square it, and we still get 4. Sometimes it's easier to do one or the other. Those are all Algebra 2 skills. Hopefully you remember them now. You just have to manipulate these to make them work right. On a quiz or a test, I'm going to give you some simple ones, but you still have to be able to show me you can do these things. Okay, we have a few more problems that have just come in, and I'll start another page and we'll go over those. Just had a few more questions come in, so I'll add these. Let's take a look at 23. Okay, so this one is e to the x equals 2. All right, pretty simple. We're just trying to put these in different forms. So this is exponential form, so we need to put it in logarithmic form. Anytime you have a base e, that means it's going to be a natural log. Okay, natural log is a log base e. Okay, and the exponent is always your answer, and the answer, it becomes the base. Okay, so the base e tells you it's natural log. If you're still not sure of that, you could think of it like this: log base e of 2 equals x, and then work it backwards counterclockwise, and you see you get the e to the x equals 2. So this is the correct answer for 23. And let's go with e to the 3rd equals y. It's the same type of thing. This is a natural log, which is base e, and your exponent becomes your answer, and your answer becomes your base. So the natural log of y equals 3. All right. Okay, number 31. We haven't done that one yet. Let's see. That's 3 to the log base 3 of 5. And the shortcut is that if the base equals the base, then the answer is just whatever we have there, 5. 5 would be the answer to that. So let's look at the other ones. 5 log base 5 of 27. Sorry, I wrote that a little bit odd. Let's try that again. So it'll be 5 to the log base 5 of 27. And again, if these are the same, the shortcut is 27 would be your answer. Okay? And the next one was e to the natural log of 10. And let me just rewrite it for you. That's e log base e of 10. So anytime you see the natural log, it's log base e. So again, if those two are the same, then the answer is just what you have. Okay, so 10 would be the answer for that one. All right, let's add another paper here, and we're going to do number 55. And they give you this graph. It looks like this. And they give you a point right here. And it's 1/2 -1. Okay. I'm sorry, that's not right. I wrote the wrong one down. Hold on a second. Let's erase this part. Okay, so 1, 2, 3. Oops. Doing this all wrong. 1, 2, 3. And at 1/2. So this point they give you is at 3, 1/2. Okay, so we need to set up y equals the log of base a x. And how this works is a to the y equals x. That's how we do this, okay? I usually have the y on the other side. So let's go ahead and fill in our x and our y. But this is our basic function we have to have. And we just fill in 2 of the 3 variables. You can't solve it unless you know 2 of the 3 variables. And we have that up here, 3 and 1/2. So 3 is x and y is 1/2. So I'm going to rewrite it in this order. The log of base a, which I don't know, of x is 3, equals y, 1/2. And so this is how we solve it. Going counterclockwise, a to the 1/2 equals 3. All right, to get rid of the 1/2, we take the, we raise it to the second power. Remember, we want our exponent to be 1, so 1/2 to the second power is 1. That's going to give us a to the first. But if we square this left side, we have to square the right side. So there we get a to be equal to 9. All right, so if we rewrite the answer, it's y equals the log base 9 of x. And that would be the graph equation of this picture, okay? So you just plug in your x and y into this form, and that's how you come up with the actual equation from the graph. All right, let's do another page and do the next problem. Okay, and then this is going to be number 71. This is y equals the absolute value of the natural log of x. And if you had your graphing calculator or you use your iPads that you have, you'll see that it gives you a really weird look to it. It's because of the absolute value function. And what these absolute value functions are doing is they're saying that no matter what you put in for x, and you take the natural log of that, y has to be a positive answer. That's what the absolute value signs mean. So if we look at, take a look at this, we can plug in values. We should be able to figure out what this is. The natural log of x typically would look something like this. If we're going up through 1, this is the natural log of x, okay? And the issue that we have is all these negative values of y that are down here. None of this on this graph can be negative. That's what the absolute value sign does. So all of those coordinates that we have here, whatever they may be, this has to be positive. The y's have to be positive. So all the x's are the normal values because they're all positive. Okay, it doesn't matter. We're putting positive values in for x. But when we get a negative value on our calculator, we got to change that to positive. So what happens is it goes like this. where all the y values are now positive for each of these x values. Okay, so let me redraw what this is going to look like if you didn't look in the back of your book. So it hits at 1 here and then goes like that. All right, so that's what it would look like. And the point is it can't be negative, so you know that the absolute value function of, the natural log function looks like this, and the absolute value just means you got to make this positive somehow. All right, and that's what we get with that picture. So hopefully that helps. I'll send this out right away.